Question 43. Which of the following is not an even function? Not even can be the case of neither, or it can be also the case of odd function. X squared is even, cosine is even, so in the end we will find an even function. X squared is even, sine is odd, so it will be odd, plus even doesn't make any sense. It is none of them. X and sine, x is odd, sine is odd, product of them will be even, plus a number which is even, also even. X squared is itself even, cosine is also an even function, sum of them becomes even, so answer is going to be B, none of them. Which of the following is true? We are going to talk about the symmetry of each function. For this question, if you want, since understanding even or odd only affects the x part, because of having x squared for both, I can also say it is an even function. Or if you cannot see clearly, you may write y alone. What do I mean? X squared y plus 4y is equal to negative x squared. You may take y as a common factor, so x squared plus 4 is equal to, sorry, it was negative, so it becomes positive, x squared over x squared. So if I write 1, I will have x squared over x squared plus 4, which is also easy to see. It is an even function having square in numerator and square in denominator and plus a number, so it is an even function. You may also write y is equal to 4 over x, and writing negative x is affecting the function. My function has minus in front, so it is a property of odd function, so not symmetry with respect to y. It should be symmetry with respect to origin, so it is a false statement. Even function has a symmetry according to y. Yes, it's true. Third one, again, if I use the same logic, take this expression other side, x times y is equal to square root of 4 minus x squared. If you use x to divide, y becomes alone, y is square root of 4 minus x squared over x. Numerator is even, denominator is odd, division will be odd, so there is no symmetry with respect to y. It is also false. Which of the following is true? Only A is a true case. Question 45. A point is 45, sorry. A point is given, and if it is on a graph which is symmetric with respect to origin, which means odd function, so which of the following point is also going to be on the same graph? If we remember the coordinate plane, they are the quadrants. Any point can be chosen as x and y. And if I am talking about symmetry with respect to origin, I imply this point. Since I am changing the coordinate of point, and since I am coming to a third one, I should change the sign of both components. So it will be logic for us. Whenever we are talking about an odd function, if a point is given, you should change the sign of both components. Change the sign of both components. Negative 4, negative 8 will be answer. If we apply same logic here, we are talking about symmetry with respect to y. A point is given, we are looking for the other point. Again, any point on coordinate plane can be written as xy. If we are talking about symmetry with respect to y, what's happening? X is changing the sign, but y is going to be the same. So negative xy will be the new point. What is the logic? X, the first component has to change the sign, but second component will be the same. Change the sign of x, don't touch the y component. 3 and 7 will be the answer. Question 47. At that time, the symmetry is not given, a function is given, but it is clear for us to understand. X squared is an even function, number is even, sum of them will be even. So here we are talking about an even function. Even function has a symmetry with respect to y-axis. From the previous question, what was the logic? If there is a symmetry with respect to y, change the sign of x, don't touch to the sign of y. Change the sign of x, don't touch to the sign of y. Answer is A. 48. A point is given and a function is given. X is odd, cosine is even, product them is odd. If there is an odd function, we can talk about symmetry with respect to origin. And symmetry with respect to origin needs changing sign of both component x and y. Change the sign of pi, negative pi. Change the sign of negative pi becomes positive pi. Answer is A. Last two questions. Question 49. Which of the following is not an equation? Not an equation of a function. Graph has intercept -1, +1, and there will be symmetry with respect to origin. X-intercepts are the case of writing 0 for y, and they are all rational functions. And till now, all the questions that we did about finding y is equal to 0 always gives us 0 numerator. Numerator should be 0. So let me look at the numerators. I have x squared minus 1, x squared minus 1, x squared minus 1, x squared plus 1. For these three cases, A, B, C, they are the functions having two intercepts, +1, -1 as a solution. But we know numerator of this function doesn't have any solution, so it cannot have any x-intercept. We were looking for, I didn't need to use the remaining part. We were looking for the function which is not satisfying the given condition. Answer is going to be D. The last question in this quiz, it is the opposite. We are looking for an equation satisfying the given condition. There are two x-intercepts, so what I am looking for, the numerator. So it is a function having two x-intercepts, right? It's okay. And x squared plus 1 has no solution, so it doesn't have any x-intercept, so you may cancel immediately. X squared minus 1, there are two solutions, plus -1. X squared minus 1, there are two solutions. Till now it is okay, but there is one more step that we are looking for symmetry with respect to origin. It is property of an odd function. X squared minus 1 is an even function. You may cancel A. I am between two choices, C or D. Numerator is even, denominator is even, so division of them is even, so it cannot be the answer. Numerator is even, denominator is odd, so answer is D. It is the end of quiz 1.